This is the team round from 2015 state competition math counts. So here we go. When the integers 1 through 7 are written in base 2, what fraction of the digits are ones? Express your answer as a common fraction. All right. So in base 2, we have, I always think of these as kind of like egg cups, so that's what these things are. Spots for things to go on. This is going to be 2 to the 0, which is 1. This is 2 to the first, which is 2, and so on. So this is 4, and this is 8. Now, I'm not going to have any 8s because we're looking at 1 through 7, right? So 1 in base 2 is just going to be 1, 1, right? 2 in base 2 is going to be 10, 1, 0, because I will have 1, 2, and 0 ones. For 3, I'm going to have 1 and a 1. 1, 2, and 1, 1. And I will continue in that manner. 4 is going to be 1, 0, 0, because I have 1, 4, 0, 2, 0, 1s. 5, I'm going to have 1, 4, 0, 2s, and 1, 1. 6, I'm going to have 1, 4, 1, 2, and 0 ones. And then for 7, I'm going to have 1 of each of them. So that means I have a total of 12 ones out of 17 numbers. Excuse me. All right. So I have 15 circles, and I need to know how many distinct sets of 3 circles, A, B, and C, that I can have all enclosed, like little nesting dolls, like those little Russian dolls. So the first thing I'm going to do is I'm going to look at the smallest combination possible. So I'm going to start with this circle, then I'm going to look at smaller circles, and then the smallest circles. So I have 1, 2, 3, 4, 5, 6, 7, 8. All right, that was pretty it's pretty self-explanatory. So now I'm going to do one step bigger. So let's go with 1, 2, 3. Okay, so that's the nesting that I'm going to be looking at. So we have 1, 2, this one, 3, 4, 5, 6, 7, 8. So I have 8 in that manner. So then, let's go to the next step. This one, and the smallest one. 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 more. You always have a haunting feeling that you're missing one grouping, don't you? I know I have another group of 8 somewhere. So this time, because right now I'm at 8 plus 8 plus 8, so this is 24, right? I don't think I have another group of 8. So then, this next one is I can go, I can't make any more with the smaller circles. I've done them all. So that's 1, 2, 3, 4. That's 28, and I can't get any more, right? Because then I've taken into account this one. There's no larger circles, so I'm stuck with 28, which happens to be the answer too. All right. Number 3, an equilateral triangle ABC with side length 12 is inscribed in a circle. So I kind of want a little more room so that it's actually, so you can actually see what's going on here. So I'm going to just make a big rectangle to cover this. Sorry, I just went bike riding and it got cold and got a little congested. So I have a triangle, an equilateral triangle, that is inscribed in a circle. Please excuse my circle, it's not going to be great, but it's good enough. And we know that this is 12, which means we need to find the area of the largest equilateral triangle that can be drawn inside of it. And so right away, it's pretty clear that it's going to be an equilateral triangle that's going to be have this as a midpoint. So I'm going to draw the center. I'm going to draw this distance. And so I know that this whole distance is going to be 12. No, it isn't going to be 12 because that's the radius. Sorry. So what I need to do, so this is a radius, and so I need to figure out that distance, right? So here we go. I know that, let's see, I need new color. How about aqua blue? So I'm going to draw this right here. And so now I have this triangle, right? And we love equilateral triangles because they make so many 30, 60, 90 triangles, right? So I know this is a right angle because I drew it that way. And I'm drawing a radius right here. And so we know that this is going to be 60, and we know that's going to be 30. And we know that this, the longest side is 6, right? Which means, no, we got crud, we don't know that. We know that this side is 6. I want to make everything 6. I'm going to get rid of that. And the reason why I know this is because this distance from here to here is 12. I know that I drew a perpendicular line through that bisected the equilateral triangle, so we have 6 and 6. And so that means that this side is going to be 6 divided by, too thick, 6 divided by the square root of 3. Now, we haven't done a whole lot of radicals, but you know that if you don't know, you can't have a square root in the denominator, right? So we multiply everything by the square root of 3. Square root of 3, so we end up with 6 square root of 3 over 3, but you know that can be reduced, right? So we get 2 root 3. So we know that this side length here is going to be 2 times the square root of 3. And we also know that that's going to be this side length as well. Because when you have a equilateral triangle inscribed in a circle and you draw the perpendicular radius, you end up bisecting both that edge and this edge. So right now we know that this is 2 times the square root of 3. We have an equilateral triangle again. So that makes that 60, this 30, and that 90. And we have this length here. So this is going to be this side length divided by the square root of 3 because of my, that's a root 3, and that's 2a, right? So that means that I end up with an equilateral triangle where the height is 2 root 3, and this is 2, and this is 2. So this distance is 4. Therefore, I have 1/2 base times height. Well, that cancels out, so I end up with an area of 4 root 3. And that's it. I don't know what I would do without, I'm caught. I don't know what I would do without 30, 60 Right triangles, I wouldn't be able to solve anything. All right. So this problem, number 4, is kind of an interesting problem in that when I did it the first time, I went a really long way. And I'll tell you how I did it, but there's another way of doing it that's much quicker. So why don't I show you the fast way first, and then we'll talk about the long, slow way, right? Okay, so Sue and Kara run along a rectangle because that's what kids do sometimes. To prove, let's say the slower one is a little kid and the other one's a sister, and whatever, and they want to have a fair race, right? And so we know that this is 120, 120, and this is 40, and this is 40. So Sue runs this distance here, 120, where Kara runs the other 3 sides because she's nice and benevolent and wants a fair race. And so she ended up running 200, and we know that they ran at the same amount of time, right? And so the time is going to be in a ratio of 200 to 120. Well, that's 5 over 3. So that we know that the amount of time is going to be related to this ratio, right? And so we know that Kara ran faster. So 2 times 3 is 6. It's going to take her 6 minutes. Kind of cool, right? So here's what I did. And then I felt like a fool. I know rate times time is equal to distance. I know that there are 50 to 80 feet in a mile, which translate to 1,760, I think. I hate to get that wrong. I think it's right, divided by 3. All right, check it out. That's yards in a mile. So what I did, since I knew the time was the same, this was her rate for 10 minutes, so every minute she went that distance times t equals, and her distance was 120. So then I found the time. Once I found the time, then I plugged it into the other equation, or an equation for 200 yards, and then I worked backwards. That's much longer. This way is better, but it will work if you have time, and there are 4 of you, so you might be able to do it. All right, number 5, an arithmetic sequence. Actually, I want to stay under the 15-minute limit, so I'm going to stop right here and pick it up in a new video.